Hello students, in this lecture we are going to learn branching in Airflow using branch Python operator. I'll directly explain it using a scenario. Consider you have a workflow like this where a task T1 is outputting some integer value. After T1, 3 tasks are listed, but the nature of use case is like that they will run conditionally. Task T1 will give control to the next task depending upon that fetched value. If the value fetched v is equals to 0, then perform the task T2 while discarding T3 and T4. If it is 1, then go and execute task T3 while discarding T2 and T4. And in case if the fetched value is greater than 1, then execute task T4. Guys, this is a very generic example I have put. Basically, all I want to state here is that in real-time projects, there are cases where your workflow have to go down a certain path based on arbitrary condition, which is typically related to something that happened in upstream task. So how you can deal with such kind of workflow requirements? The answer is, to handle these such scenarios, Airflow has provided us a technique called branching, with which we can easily write down these workflows in a DAG using a special operator called branch Python operator. So what is branch Python operator? The branch Python operator is an operator that helps a great way to execute conditional branches in your workflow. You can consider this operator much like the Python operator, as this too has the Python callable parameter. But the difference is, unlike in Python operator, where your Python function can return anything, here in branch Python operator, your Python callable function can only return a task ID or a list of task IDs to which the control is to be given after meeting the specified conditions. Enough of the theory part, let's dive into the code and write a DAG for branch Python operator. Giving you the brief idea of this example. In this example, we will pass some integer value from first task to second task. Second task will check if the value retrieved is either even or odd. And depending upon the value, it will give the control to either of the tasks. If the value is even, then even task will execute. If the value is odd, then odd task will run. Let us create the code of it. Like I said, that for this example, we will be sending a value from one task to another. It means for sure we have to use XCOMs here, which we have already covered in previous lecture. So let me directly paste the code for first task, which would be pushing the integer value. This is a very simple XCOM example at this stage, where push task is calling this push function defined here to push an integer value 4 as XCOM. Now the second task we need will be to retrieve the XCOM value and also check whether it is even or odd. So define it. Branch task is equals to branch Python operator. To use it, I have to import now its parameters. It's task ID, then the Python callable function, and provide context to true. Now define this branch function. In this function, first we are pulling the XCOM value and storing it in a variable pulled value, and then we are checking if that value is even or odd. One thing to note here is, unlike we can return anything in Python function, here as we are calling this function in branch Python operator, so we have to return the task ID referencing a downstream task that will get executed after this task. So if the value is even, then return task ID as even task, and for the odd value, return odd task. These even task and odd task we are creating next. Even task, using a simple bash operator, I am printing a message got an even value, and similarly in odd task, I am printing got an odd value. And keep in mind to always create the task with same task ID that you are returning in branch Python operator's callable function. Okay, we have all the tasks ready. Let's define the operator relationships. Push task will execute first, then branch task, and next, after one of this condition is met, either of the even or odd task can execute. So put them in a set. Excellent. We have created a DAG that will run depending upon the arbitrary conditions. Let's now run it. So first the push task will execute, then the branch task, and after that, depending on the conditions met, one of the tasks, either even or odd task, will get executed. Refresh it again. Great. Out of 4, we have 3 tasks marked as successful and odd task has been marked as skipped for obvious reasons. This was for even value. Let's change the push value to any odd number now. This time, even task was skipped and the odd task was executed. Alright, now guys, one important point I would like to add while you use branching. Using the branching method with property depends on past set to true is logically unsound and quite risky. Why? If you remember, setting the property depends on past to true will make the specified task instance to run only if its previous run was success. Right? Now consider the same example with depends on past set to true. For the first DAG run, even task was chosen and the odd task was skipped. And in the second DAG run, odd task was chosen. In this situation, with depends on past set to true, since for the first DAG run, the odd task was skipped and it did not run, so it will not allow it to run for the second time as well. So this situation will invariably lead your workflow to block tasks that depends on their past success. And as a result, you will be locked in your data pipeline. That's why it is recommended to not to use depends on past property when using branching. Great. So that's how using branch Python operator, you can code your workflow whose execution depends on some conditions. Now you can think of some conditions and try it implementing in our store sales project. Thank you.